we're here. Let's go for it. So, do this first. Great. Alright, now everything's just where I want it to be, so we'll get started with inverse trig functions. Inverse trig functions. And the first thing that I want to tell you about inverse trig functions is that none of the basic six trigonometric functions has an inverse. That's a single one has an inverse. And this is true because all six of the trig functions are periodic functions. And if we remember what we remember about inverse functions, they have to be one-to-one. They have to be monotonic. And, if I just quick sketch the sine curve certainly isn't going to pass a horizontal line test, so it should not have an inverse. Okay? So if the story ended right here, we'd be done with the video and we'd move on. But we all know that we have inverse trig functions. We all know we have inverse trig buttons on our calculator. So what needs to happen is their domains can be redefined in such a way that they all have inverse functions on a fixed interval. So they all have the inverse functions on some sort of an interval within each function. Okay, so otherwise, we wouldn't have much of a story to go with. So let's talk about what those intervals are. Okay? So when we're looking at this, so y equals the arcsine of x if and only if that was Miss Gilbert. She just popped in for a moment. So where were we? Oh, we were going to look at what this all means. So y equals the arcsine of x if and only if the sine of y is equal to x. So this is the notation that we use. So the domain, which is the possible x values, is from -1 to 1. And that's the output. The output of the sine function goes from -1 to 1. The range on the sine function has to go from -π/2 to π/2. Okay, as we work through, so if you think about what that sine curve that I showed you just a few seconds ago, there's 0. So what we look at is we take the sine curve back to here, and between here, -π/2, and there, π/2, the function is monotonic. It's 1-to-1, so we can get an inverse out of it. Okay, the domain of the arc cosine function is also from -1 to 1, and it exists between 0 and pi. So again, cosine function looks like that. That one's not monotonic, but if we just look at from 0 to pi, it works out that we have that ever-increasing sort of function, or ever-decreasing sort of function, so it works out. Similarly, the arctan goes from -infinity to infinity, and its range is from -π/2 to π/2. Okay, as we work it out. And remember, the sine function is the one that looks like it kind of does that sort of thing, and then it has an asymptote, and then it does the same thing over again. And so within the asymptotes, it works out, it's all fine there, and that's between -π/2 and π/2 as it goes there. Our cotangent, I'm going to quick blow through these. Go from -infinity to infinity. This one, the absolute value has to be greater than or equal to 1. And likewise, this one, the absolute value of x has to be greater than or equal to 1. These are from 0 to pi. And I'm brushing through these quickly because we don't spend a lot of time on the domain and actually on the graphs of them, so it doesn't mean a whole lot to us anyway. But these first three definitely do, and we have the buttons to make these all work out, so we just need to understand what it is. The alternative notation for the inverse sine function is the sine to the -1, and it's one of those unfortunate notations because, sometimes sine to the -1, you would think it means 1 over the sine, which is the cosecant, but in this case, sine to the -1 means inverse sine, so a lot of times we tend to use this arc thing because we don't want to confuse people. Okay, same notation means a couple of things, but anyway, here we go. So if we want to evaluate the arc sine of -1, so what we're asking for is what angle has a sine of -1? Okay, and so we know that I'm just going to kind of draw in, here's my sine curve, right? And there's the other part of it. This is the part where it's defined from -π/2 to π/2, which is right there. So the angle whose sine is -1 is -π/2. You can use your trig card, and it'll sort of get you that same answer. You probably would have gotten 3π/2 for that back over here, but that's not in my inverse domain. The angle whose cosine is 1/2. I would use the trig card, and I would say that that is going to be pi over 5/3 cosine. That's that one, right? Let me just draw the right triangle just to be sure. So 1/2 is going to be the 1, 2, √3 triangle. Cosine to be 1/2. We're talking about adjacent over hypotenuse, so it's this angle right here, which is my bigger angle, which is the pi/3 angle. So that's right. Okay. And then evaluating evaluate the function whose cosine is 0.85. Here's where we don't have that on our trig table, so we just run to the calculator. Go large screen. I don't know where I am, so we'll get to second quid. And we're just doing inverse cosine, so that's second cosine of 0.85. Enter. That's 0.5584, and I just want to make sure that I'm in radian mode before I get too far along. Yep, great. Second quit. So it's 0.554 radians, or 0.555 radians would be what we'd be looking at here. So 0.555 radians. Okay, there you are. So that's how those work. We might have a problem like this. The angle whose tan, there's an arctan of 2x minus 5 equals -1. So what we need to find out is what angle has a tangent of -1. I'm not sure right off the top of my head, so I think it's one of the pi/4s, but let's just do it. So second arctan of -1, boom, boom, -0.7853, which I think is pi/4, but let's just check. Second pi divided by 4, boom. Yeah, so it's -pi/4. So back to the story. So then the arctan of 2x minus 5 is this. So that means the 2x minus 5 is equal to -pi/4. With me? And so then we just solve it. 2x equals 5 minus pi/4, and x equals 5 minus pi/4 divided by 2. Okay, which is an exact answer. That's an actual answer. If we plug that in someplace, if we leave it as it is, it's exact. If we actually go through and use the calculator number, that 0.78 number, we're going to get a decimal number that's not going to be as exact as this. Okay, if you're doing this and your calculator gives you 0.78, whatever, you want to use that to solve the problem, that's probably okay for now, but realize it's not as exact as we get otherwise. Okay? We're going to see some problems like this. We're trying to find the cosine of the arcsine of x. So we're going to try to find the cosine of the angle whose, because that's what arcsine means. So we're trying to find the cosine of the angle whose sine is x. So we've got some angle. I usually call it angle y. There it is. And its cosine, or I'm sorry, its sine is x. So when we're talking about the sine, we're talking about the ratio of the opposite to the hypotenuse. So the ratio of the opposite side from y to the hypotenuse is x. So the way we get that is opposite side is x, hypotenuse is 1. X divided by 1 is x. Okay? Then we need to figure out our third sine. We use Pythagorean theorem to come up with that the third side is 1 minus x squared, square root of that. Okay? So now, what we're left with is, what's the cosine of y? Cosine of y is the ratio of the adjacent to the hypotenuse. So it's the square root of 1 minus x squared over 1, and I'm not going to write over 1 because we just don't do that. So we start with these ones. You draw a triangle. You try to make the thing work out to what you want it to work out to, and then you just use, SOHCAHTOA to get the rest of the way through. Might have something like this. The tangent of the arc secant of some angle is √5/2. So the tangent of the angle whose secant is √5/2. So here's where we need to remember what secant actually is. Secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse. So this must be hypotenuse over adjacent. So I've got my angle. The hypotenuse is the square root of 5. The adjacent side is 2. So then I've got to figure out, well, what is that missing third side? So I would use Pythagorean theorem. The square root of 5 squared minus 2 squared equals, square root of 5 squared is 5. 2 squared is 4. 5 minus 4 is 1. Square root of 1 is 1. Okay, so this side is 1. And now I can find the tangent of this angle. So tangent of y, that's my angle, is the opposite over the adjacent. It's a half. Ta-da! Okay? Keep saying ta-da. I need a new word. Shazam? Finale? No, there's that. That's what we're going to work on tomorrow in class. Go back. So with these problems here, these later ones, always draw the triangle. Put the y in there, figure out what its angle is, use Pythagorean to get the rest of the sides, and then Sokotoa, Shoshack, Teo, get to the rest of the way. Okay? So that's all. That's it. That's enough. Thanks for watching. Thanks for listening. Hope you learned something. You know where to direct your questions. See you tomorrow. Bye-bye.